Assalamualaikum. Today we will be presenting our Csc435 project, which is traffic and pedestrian simulator. We would like to start with introduction of each member of the group, starting with Ashura.
Hi, my name is Narsha Nabila binti Muhammad Sanjid. My task in coding is traffic light and timer.
My name is Wan Ali Sofia and my part is road design.
My name is Nuraida binti Muhammad Zain. My part is to make the buttons and the sound.
And my name is Manu Shafika and my part is car and...
This is a Java-based smart traffic and pedestrian simulator that models how car and pedestrians interact, traffic at an intersection. We use Java Swing to build this project, and it includes a few key features. First is realistic braking. This means car automatically slows down and stops when the light turns yellow or red. Second, the pedestrian safety. The coach actively checks the crosswalk. If the pedestrian is on the road, car will stop instantly and to avoid an accident. Third, interactive controls. User can click a button to pause the simulation or stimulate a pedestrian, pressing a button to cross, which changes the traffic lights manually. And lastly, we add the sound effects like traffic noise and countdown beeps to make the whole simulation feel more realistic.
And I will talk about list of features. First, traffic light control. Light change automatically every 1 minute. Clear color-coded lights display on the intersection diagram for easy to interpret traffic light state at a glance. Second, road layout and zebra crossing. The horizontal road is connected with a vertical zebra crossing, so vehicle move from left to the right and pedestrian cross safely from top to bottom. Next, car and pedestrian. Pedestrian walk only appears when vehicles are stopped. Cars move horizontally with engine sounds when the light is green, while pedestrians cross vertically on the zebra crossing when the light is red. Lastly, button and sounds. Pressing the start button begins the traffic light cycle, with cars moving horizontally accompanied by engine sounds and pedestrians crossing vertically on red.
For the main output of our system is a real traffic simulation that controls both vehicle and pedestrians. First, the system manages vehicles and pedestrian movement according to the current traffic light phase. Second, pedestrian can safely cross the road by pressing the crossing request button, and the system displays a countdown timer during the crossing period. Third, the traffic light automatically transition between green, yellow and red without manual intervention. In addition, the system includes a collision avoidance mechanism where the vehicles slow down or stop when pedestrians are crossing. Finally, visual indicator and audio alerts such as traffic light display, countdowns, warning beeps, and vehicle horns enhance the realism of the simulation and improve safety.
I will start by presenting my part regarding button menu and sound. To start, let's look at how the user interface controls our build. In section 3 of the constructor, I set up the system control desk using the basic flow layout inside the container panels. We have 4 primary control components: BTN start, to pause and play the simulation; BTN pedestrian request, to manually trigger a crosswalk change; BTN sound, which is the J toggle button acting as our audio master switch; and a standard BTN exit button. To ensure realistic behavior, the pedestrian request button is explicitly disabled by default using the set enable false. It only becomes clickable when the vehicle light turns green, ensuring the pedestrian can't disrupt the flow at the wrong time. Next, inside the setup event handling method, I attach action listeners to bring this button to life. The simplest but most crucial button for cleanup is our exit button. When clicked, it does 2 things. It immediately triggers our UI feedback. Sound, click wave, it executes system exit 0. passing 0 as the status code tells the operating system that the program is terminating cleanly with no error. Now, let's talk about the sound architecture, which is split into two distinct engines, ambient background noise and instantaneous event audio. For the background, I create the initialized ambient traffic noise method. This uses javax.sound.sample package to load a file named traffic_noise wave. It set up a persistent clip object. So, whenever the simulation status change, update ambient traffic noise state checks our sound toggle button. If the simulation is running and the sound is enabled, it loops the traffic noise continuously using the clip loop_continuously. And if the user hit pause or mute the audio, the clip instantly stops. For targeted sound events like button clicks, car horn or countdown warnings, I implemented the standalone play sound helper method. It dynamically opens, start and discard short audio clips on the fly, preventing the lag. This ties beautifully into our pedestrian request button and global timer. If a user hit request crossing during a green phase, the listener instantly play the click sound, disable the button to prevent spamming, and force the traffic state straight to a 5-second yellow phase. Furthermore, inside our 1-second global clock loop, if the countdown falls below 5 seconds during a critical red or yellow state, the system actively queries the is sound on state to pulse warning beeps, signaling to pedestrians and drivers that a phase transition is needed.
Today, I will explain the road design of our smart traffic light simulation system. The purpose of this scoring is to create the road environment for the simulation. It provides the basic layout where vehicles and pedestrians can move safely. Without this, the traffic simulation would not have a proper road structure. Next are the road components. The system consists of several important elements, including the main highway, sidewalks, zebra crossing, lane divider markings, and traffic light positions. Each component is carefully positioned to create a realistic road environment and to support both vehicles, traffic, and pedestrian crossing. Now I will explain how these components are implemented in the code. First, the FIRAC method is used to draw the main road and the sidewalk. The road is displayed using a dark gray color to represent asphalt, while the sidewalk are drawn in light gray to separate pedestrians from the road. Next, the draw line method is used to create the lane divider markings. A dashed line pattern is applied to make the road look similar to a real highway. For the zebra crossing, the program uses a for loop instead of drawing every white stripe one by one. The loop repeatedly creates multiple stripes across the crossing area. This makes the code more efficient, shorter, and easier to maintain. The system also uses coordinate variables such as walk x1, walk x2, and horizontal road y. This variable determines the exact position of the sidewalk road and pedestrian crossing, ensuring that all road elements are properly aligned even if the window size change. Finally, the result of this module is complete and realistic road layout. It provides the foundation for the traffic simulation by creating an organized environment where vehicles, pedestrians, and traffic lights can interact correctly.
Then I will explain about the cars and pedestrian parts. First, I program the entity position. This allows the pedestrians and car to appear at a specific starting point on the screen and move to the correct destinations. The position is continuously updated so the movement looks natural. Second, I implement smooth decelerations. Instead of stopping suddenly, the pedestrians gradually slow down before reaching the destinations. This creates a more realistic and comfortable animations. Next, I also program the pedestrian movement. The pedestrian walks from the starting position to the target locations at the control speed. The movement is continuous and follow the path defined in the code. Lastly, I design the color and shapes of the entity. The pedestrians and car is displayed using a simple shapes with a distinct color, making it easy to identify on the screen. This also improves the overall visual appearance of the simulations. Overall, these features work together to create a smooth and realistic pedestrian and car simulations with a clear visual, natural movement, and controlled stopping behavior.
For traffic light and time part, firstly I set up the basic logic number for our light such as 0 for greens, 1 for yellow and 2 for red. The system is programmed to start on greens for 20 seconds. Next, I simply create the text label that will show up on the screens along our main countdown timer variable. Next, I design the layout for the text panel on the top of the window. I use a simple grid with bold fonts for the user can easily see the live status of the traffic. The next part is the actual engine that handles times. It takes every 1 second and counts down when the timer hits 0. It automatically switches pace from green to a 5-second yellow, then to a 20-second red, and loops back smoothly. I wrote the code that updates the text and color on screen in real time. This is where I put our safety rule. Pedestrians only get a green light to walk during the first 10 seconds of the car's red light. The last 10 seconds turn right to let them safely clear the road. But not least is handle the visual graphic. Is draw the physical traffic light box on the screens, read the active state and light up the correct green, yellow or red signal over the post. That's all. We will go to the next part.
Hello everyone, this is the demonstration video for our Csc435 project that we built by using JavaScript. Our project is called Smart Traffic Light Simulation System that control both car and pedestrian at the same time. When I click Start Simulation, the background traffic sound starts. The traffic light turns green for 20 seconds and the orange car can drive smoothly across the road. The magenta dots are pedestrian and they must wait safely on the sidewalk. Now, let me show you our smart feature. If a pedestrian wants to cross a lane, they press Request Crossing button. And you can see how the green light changes to yellow right away for 5 seconds. This causes the car to slow down and stop suddenly. And you can also hear the beeping sound that indicates the car needs to stop to allow the pedestrian to walk. Traffic light turns red, the car stops completely, and for the first 10 seconds, the pedestrian light turns green. So, the pedestrian can cross the road safely. We also put walk sign with green color on top of it. And in the last 10 seconds, the pedestrian light changed to red. And we also put a warning for them not to walk. This gives the people on the road enough time to finish crossing before the car moves again. We also have a sound button to turn the traffic noise on or off easily. Finally, there is a built-in safety scanner. If a pedestrian is still on the road when the light turns green, the car will beep its horn and brake automatically to avoid an accident. That's all for my demo. Thank you. That's all from us. Thank you. Thank you.